Hello engineers. Today we are going to see a very simple introduction in the schematic editor and simulator of hTdA5. When you execute the program, you will have a workspace. On this workspace we are going to put the circuit elements that we call placement. In order to make a placement, we will have options here from different menu items or toolbars. First of all, for the very basic circuit, let's insert a voltage source. When you click on it, you will have just the figure attached to the mouse. Every circuit needs a ground, so click on the ground, move the mouse down, leave it. We will use a simple resistor and a semiconductor, a diode. For simplicity, let's right click on the diode and choose rotate left. Now, once we have the placement finished, we can click on the source, double click on the source, and then we can edit the parameters of the voltage source. We are going to edit the voltage from 5 to 3. Similarly, we can double click the resistor and change it to 2K. Okay, we have to use a lowercase key. And if you double click the diode, we will see lots of possibilities to choose from. Let's choose 1N4001, a standard diode. When you click on a diode, on the right hand side, you can see the circuit simulation parameters like the saturation current, the emission coefficient, the breakdown voltage, which is the maximum voltage that you can apply to obtain for the Zener operation. And you click on. Once you place the components, the next step is to connect the terminals of the components. For this, we will insert wire. Now, you can simply click and move the cursor in a rectangular coordinate system. In this way, we have obtained our first circuit. The essential point is every component has to be connected. That is, the terminals have to be connected to other circuit components. In order to verify this, you can apply an electrical rule check, ERC. As you see, the ERC is okay without errors and warnings. The next step is to add an output element. For this, go to the meters. The first element is a voltage pin. Move it to any point. But if you leave it like this, and if you apply a ERC, you will get an error. The voltage pin VF1 is floating. Pin 1 and pin 2. So you have to move it, and then a connection is achieved. Then we can apply a DC analysis. DC transfer characteristics. Then it will ask you, oh, we have still the pins of VF1 are floating. Remove it. Click again. I hope now, okay, it is connected now. If you go to analysis, DC transfer characteristics, there is only one source, R1, a voltage source VS1, and R1, which you can sweep. We will just say, okay, let's sweep the source VS1 from 0 to 2 volts and Just use 100 data points in between. Okay, this is what you get. So for every input you can see the output. As you see that the diode is always reverse biased for voltages in this range. So let's do the analysis again, where we sweep the voltage from minus 2 to plus 2, so that we get our output characteristics. This is called a DC analysis or DC sweep analysis in a more correct term. Have a nice simulation.